guys and gals. How you doing? Thank you for hitting the play button. Appreciate you being here. Johnny Whiskey Tango Sharp. Coding, mathematics, kind of got it. Kind of got it all over here. A little bit of everything. Appreciate you being here, guys, gals, parents, students. It's great to be back. So kind of got to get into the streaming vibes again. But let's go! You guys are awesome for being here and watching. Here to support homeschooling parents and students that may possibly need some extra support with mathematics. Here to help, guys. Here to help. So I think let's just get going, right? The main goal is to kind of try to keep the videos not too long. So great to have you here. Appreciate you being here. Let's learn, guys. Flick that switch in the old brain molecules. I don't know, in the head. And let's learn some math. Let's go. Quickly, should check the stream, make sure we're good so you can hear me. Well, the main goal is to confirm that you can hear me. In the head. And that is true. So let's go. Right on. All right. So where were we last? We were. Let me get my little sheet up here. See, where were we? I know I have it right here in front of me, but I just have to look through here on my documents. Okay, we've done that. Okay, yes, I found it. All right, let's go. Want to kind of finish this section of mental mathematics. Again, this is just kind of extra for you guys. A lot of it's just basic life mathematics, general stuff that you would use. And then I'm going to get back into kind of just regular grade 10, I don't know, grade 9, grade 10, grade 11 mathematics curriculum. Okay, guys? Here to help. Parents, I support you in your decision to homeschool your child. I fully understand, and I'm with you. So, leaving it at that, let's learn. Okay, so we had candy here, and we're purchasing some random candy from maybe our distributor or whatever. It's all hypotheticals. Regular price is $40, and because we are a frequent, our distributor likes us, let's say, we buy a lot of product from them. And so they're going to give us a, special company discount of 40%. Woo! That is pretty good, boys and girls. That is pretty good discount. So now we have to figure out what is it going to cost us? Okay, what is it going to cost us? So what we need to do is, let me bring my eraser here. It's pretty basic, quick math. There's a couple of things we could do. I guess we'll just try to simplify it. I just want to erase this. Okay, we got to figure out our cost. That's kind of unknown, right? Turn the eraser off. So we could do a couple of things here. We could go like this. We could turn our 40. Remember, our magic number is 100 when we're working with percentages. So to get it to a decimal point, we basically go 40 divided by 100, or we could just cancel a couple of zeros, right? The math works out the same, guys. I could have a whole series of zeros here. As long as they're the same number of zeros, I could cancel. Basically, it's reducing in a nutshell. Okay? So with that said, let's carry on. So I'm just going to redo that. So we have 4/10. And if you worked with fractions and such long enough, you'll know that 4/10 equals 0.4. 0.4. Now, how I kind of figured that out in my head was basically we want to take the decimal here on the 10 is a singular jump. So basically we want the decimal behind the 1. So we're going to be doing the same thing here. So we're moving the decimal 1 jump, which puts it there. Okay, so 0.4. Again, you could use a calculator, guys and gals, to confirm. You know, a lot of this might be pretty easy for most of you, but, you know, a lot of people, they're young and they're learning, or they're maybe just new to it. Who knows? Whatever the reason is, I'm glad that they're here learning. So 0.4 is the correct answer. Okay, so that's what we have. So with that said, now that we have that done, we could just kind of write that number on the side. So now we got to take that 40% and basically multiply it by our $40. So I could write out and show you the long math. Essentially, we would have 40 over 100 multiplied by 40, right, which is our $40. Okay. And going over it again, guys and gals, it's the same thing as, 40 is basically 40 over 1, right? So we could do the long math. We could go 40 times 40, 100 times 1, which would give us, 1,600. This is how I do the quick mental math, guys. I just look at the first set of numbers, ignore the zeros. I go 4 times 4 is 16. And because we're multiplying, right, I have 1 0 here and 1 0 here, which means I'm going to have 2 zeros here. And that's going to be all over, 100 times 1 is 100. And I could do the same thing. I could cancel the 2 zeros, cancel the 2 zeros. And basically, I have 16 over 1. Oh my goodness, that was pretty quick, huh? Showing you that. So that's one way of doing it. Or we could go like this. I mean, I guess it would work doing it this way. We could take our 0.4 and just multiply it by 40. Okay, on our calculator, obviously it would give us the same answer. So times 40, we should get 16. Okay, but let's see, how do we work? It's better to actually do it the way that I was showing you. Can I undo all this? No, I can't. Can't get all my work back. That's okay. But my point is just to work it with fractions, and it's a lot, because obviously going 0.4 times 40, you know, it's a little bit more trickier to kind of figure out that number, right? Whoops, I'm already thinking the answer, right? Essentially, that's what we would be doing, going 0.4 times 40. It's the same thing. Let's just get this done quickly. I think this is the best way to do it. So we go 40 over 100, which is our percentage. Bring our $40 down here. That's over 1, right? Do the straight multiplication. Again, working with fractions, when you're multiplying, guys, there's no reason to be afraid of fractions. When you're multiplying and dividing, it's so easy. It's just straight multiply the numerator, straight multiply the denominator. It's that simple. So I go 4 times 4 is 16. And then I just bring my 2 zeros over, 1 and 2. And then same thing here. Well, anything times 1 is the same number. So our number is 100. So we just go like this. And again, this is a lot easier, right? Now we just simply cancel the zeros. It's that easy again, guys. So we're left with 16 over 1, which equals 16. Okay, there's our answer. Let's drop some yays and go on to the next problem. I just had to have some coffee. Okay, so I need to, because I saved this, I'm gonna have to. Oh, that actually what? That works too? Crazy. I'm just gonna undo all this, just kind of erase most of it by going undo. And that's as far as I can go, so I'm gonna have to go like this. Eraser mode on. Insert eraser mode music here. That's just a reminder for me for editing. Appreciate you guys and gals being here and learning. That's truly awesome. Thank you for your patience with me. Trying my best, doing my best to help you guys out. Again, I am a math major. I majored in calculus. Well, I majored in mathematics, and then I also majored in calculus. It's been a minute since I've been in college, but for me, this is just basic mathematics, and it's still pretty easy for me. So, not to get into too many details, but I think personally, more qualified than somebody that is supposed to be a teacher slash instructor, but they're not teaching the course, they're teaching other things that they shouldn't be teaching. So that's why I'm here. Okay? To teach you guys and gals mathematics. Staying on topic, again, you know, you're paying for whatever, the school, the teacher, the program, your course, your tuition, or whatever it is. It's the way it should be. It's your money. You should be learning the subject, period. All right, and I do my best to give you guys quick tricks and tips, trips and ticks. Get my English out today. I do my best to give you guys and gals good, quick tips and tricks. That was a tongue twister. Whew! I got it though. I did it. I did it. I just thought I would throw that in there. Okay. Next problem. So yeah, appreciate you being here. All right, rewrite the following fraction in lowest terms. Okay, so we're reducing, guys. Okay, let me fix my, get my pencil or marker back. I'm using, in case you guys know, I'm using Krita software, and it's free, open source. Basically, obviously, coders, artists kind of grouped together, worked together, collaborated together to create Krita. It's a free open source software. It's really great, guys. To be honest, I've been wanting to teach mathematics for probably about 4 years now, and I just haven't had the right medium to teach you. I didn't want to do whiteboard and wonky hold my camera stuff and do videos that way. So it took me a bit of years of trying to, I didn't have, I'm like, how am I going to teach mathematics? What's the best way for me to do this? Because I didn't have anything I could write with. And Krita is one of them mediums. So thanks to Krita. Not a supporter. I mean, they're not a supporter of the channel, but highly recommend the software. Again, if you want to learn to do digital art and you're an artist or whatever, it's great for learning how to practice sketching and doing artwork. Right? You could use it for that as well. All right, let's carry on. So I am thankful for Krita so that I could do this. Again, I'm hoping that things grow and get better. I'm trying to be consistent with the videos for you guys and gals. I know I'm getting a bit off topic, but just letting you know. I know I took some time off and such, but I do eventually get back to it. I do videos, random videos here and there, and the main goal and focus is to kind of continue this mathematics thing. Now I know I've been doing Unity projects and such. There's been views and whatever on that. That's great, but personally, I think helping the world, those that want to learn mathematics, I think that's more important. So, but yeah, that's why we're here. So here to help. Eventually, I'll probably get into doing Unity stuff again. I know I have a project that I was working on, but I just kind of get bored, I guess, to a point, and then if there's just not enough interest, then I just kind of carry on to something else. Mathematics, to let you know, always interests me. So, all right. So they're giving us 18. Let's carry on. Okay, I didn't get too off topic. Just kind of giving you guys an update on what I'm doing and what I'm planning and what I'm thinking. All right, so fractions. Again, guys and gals, don't let fractions scare you. It's just a number over the top of a line, all over top of another number. Right? I mean, it'd be like, oh look, I have a circle inside a square. I mean, does a circle inside a square scare you? Not really. I have a number over top of a line, which is over top of another number. We're reducing here, okay? So, yeah, you do have to think a little bit, okay? But this is where I always recommend you guys, like, spend the time right before bed or whatever. Just quickly study, have a times table. Now, I actually might have a times table here for you. I'll open it right now. So you could actually take this if you're on maybe a laptop. I'm just assuming you're on Windows. We have for Windows software called Snipping Tool. Okay, and you could just quickly go snip. Just do a little kind of a screenshot essentially of it. Save it. And then print it off. So it's there for you. Okay, and then you don't have to make one out, and you can kind of just study that. So the reason I recommend that is you need to kind of figure out common numbers, right? And that's why it's important, right? So looking at this, we can ask ourselves, what's our common number? I want to take the most meat off the bones, right? I call it, I don't know why I use that as a euphemism, is that the word? But the idea is to get you to understand, you want to find the largest common number. That's what I mean. You want to find the largest common number. And 9 is the number. Okay? Which obviously equals to 1. That's the idea. We want two common numbers. We want a common number for our numerator, and we need a common number for our denominator. We essentially want those to cancel each other out so that it equals 1. That's the main goal of factoring and reducing, guys. Okay? Again, if you're planning on majoring or going to college or university, again, it's your money, your tuition. I think you personally have the right to demand that your instructor teaches the subject that they're supposed to teach, and that's it. Okay, with that said, factoring, like if you plan on going to college or university, you're going to be doing a lot of factoring. I'm just going to let you know that. Like, I don't have there's so many different areas of mathematics. You use factoring a lot. I mean, even radicals in that. You could factor with radicals. I believe there's even factoring and reducing when you're doing calculus. Been a minute, but factoring is kind of one of those things that you got to get used to doing. Okay, so your times table is memorized, so you know that 2 times 9 equals 18. I'm just going to write the numbers here. And you know that 3 times 9 equals 27. Okay? Right? You can almost see the fraction already. This is the most meat off the bone right there. I could literally, I already see the final answer just looking at what I see here. Okay, so just to show you, we're gonna do this. So 9 is our common number. Okay. So now at this point we go, what times 9 gives us 18? Well, that's 2. What times 9 gives us 27? That's 3. Now I can bring up the times table to confirm that. 9 times 2. Hopefully I didn't mess this up. This is the 2 right there. Okay. 9 times 2 is 18. 9 times 3 is 27. Okay. Big correctamundo. So again, just like I said, guys, we want to find a common number. We want them to cancel so that both of these equal to 1. What we're left over with is 2 over 3. And you're done. That's it. That deserves a yays. Okay, again, if you find that largest number, you might have to reduce a couple of times. There's nothing wrong with that. Maybe, you know, your fraction's a lot larger than this. You know, maybe you don't find that largest number. Maybe you're not quite reduced quite yet. Well, that's fine. You might have to reduce a couple of times. That's fine. You might have to reduce, you know, 3 times. That's fine. Obviously the end goal is to get it to the lowest point where you can't reduce it anymore, right? Obviously 3, if we divided 3 by 2, well, we're gonna get a decimal value, right? So we can't reduce anymore. Of course, there's no common number between the two, so now we know we're done. That's the final answer right there. Whoops. Okay, I'll double check. 2/3. That's correct. Oh, what did I do with that other one? Did I mess things up? I got 20. Is that correct? How come I got 16? What is the cost after it? Oh, okay. Maybe I messed that other one up, guys. I should have looked at the answer. Remember I had 16. We were doing 40%. Right, I see. I didn't do the work properly, guys. And I apologize. So going back to that other problem quickly, we figured out that 40% of 40, my apologies, equals 16, right? That's the discount. So essentially we would be subtracting that 16 off the 40. So what we're going to end up paying is 24. I apologize I didn't finish that problem. Okay, just to go back on that prior question. Okay, that's enough. That's all I'm gonna do to talk about that. But yeah, that's essentially what we wanted to do. Okay. All right. Let's go on to the next question. Some of you may have noticed that, and that's smart of you that you did. That's awesome. Truly is awesome that you did. So yeah, that's big yays for you for sure. Okay, so here we go. I kind of want to push through these, and I feel like I take too long on some of these problems. I want to try to push through them a little bit quicker. Okay, thank you for understanding. Okay, there is a 50% discount on all candy at the store the day after Halloween. If it costs you $30 to buy candy before Halloween, how much would you spend if you bought the same candy after Halloween? Okay? All right. So that's going to be pretty easy and quick, okay? It's exact same thing, guys and gals, right? Okay, 5/10, which we know 5 goes into 10, right? So we know that's 1/2. I guess I'll show you the work. Okay, this is what I did. I went 5 times 1 all over 5 times 2. 5s cancel. I'm breaking it into parts, really. It's the same thing. This means exactly the same thing as that, which is 1/2. So, and obviously, you know, if you think of halves in money, well, 50 cents would be, right, 1/2, half of a dollar, right? If you think of it in terms of money. Okay, so we have 1/2. All right, so we could go 1/2 multiplied by that 30 all over 1. Again, if you keep it in fraction form, it's so much easier versus just trying to multiply it with a decimal. Things work fine if you're working with 100, but anyways, when you're doing the decimal jumping, I mean. All right, let's see. Okay, so if it cost you $30 to buy the candy after Halloween, well, basically we're going to be paying for half, right? So, so what we end up with is 30, right? 30 times 1 over 2. If we reduce this, which we can, right? A lot of you probably already know, like, we could think of this like logically like this. We know 10 plus 10 plus 10 3 times is 30, right? We know this. Okay, so if we take one of these 10s and split it into 5s, we'll put that 5 there and that 5 there. We're left with 15 over 15. Okay? Which equals 30 as well, right? This is the same thing as saying 15 times 2, right? Which equals 30. I know it's kind of simplistic, but I'm going to go over it anyways. Okay, so now we know we have a common number, right? Just trying to help you guys with mental math in your head, right? You understand what I did there? Just to figure things out. I broke this into parts. I just took one of the 10s and broke it in parts. I went 10 plus 5 gives us this. 10 plus 5 gives us that. And that's it, right? I just took one of the 10s and split it. It's all the same thing, guys and gals. Okay, so now that we know that 2, that's our common number we're looking for is 2. Same thing with here. Our common number is 2. What times 2 gives us 2? Well, that's 1, right? That's the missing number. So these 2's cancel. We're left with 15. And our answer should be $15. And that's what it is. Bear with me, guys. I take advantage of having some coffee at that moment. Okay. Let's clean that up. So that's some quick money math, I guess. If you think of it that way. Next question. What is the mean of? So they're asking what is the mean? Okay, so this is like statistics. Okay, don't let it scare you. They have 3 terms: mean, medium, and mode. We're not going to talk about them all right now. This is, again, statistics. Probability statistics is kind of like this. I'll give you a quick example. You have 52 cards in a deck, right? What is the probability of pulling an ace out of that deck, right? We know we have 4 aces, right? Okay, we have 4 aces. So that means we have a probability of 4 out of 52 of pulling an ace. Okay, essentially that's kind of what we're getting into a little bit. Okay, I don't want to go too far on a tangent, but they're asking about the mean. Okay, so I'll give you a definition. What definition of mean? And then I'm just going to go mathematics or something. I really hate the way I type. My typing skills really suck. Don't cheat in typing class in school, guys. Okay, that's what I recommend. Okay, what is the mean in math definition? Okay, in mathematics, the mean is a type of average calculated by summing all the numbers in a data set. Okay, so our data set, so you understand what they mean by a data set. Our data set is this: 3, 4, 6, and 7. Okay, there's our data set. They can mean anything. Let's say you had Bob had $3, Jane had $4, Rick had $6, and Henry had $7. Right? Well, what's the mean of all the money if they put it all together, sort of thing, right? That's kind of what we're figuring out. Okay, so our data set is 3, 4, 6, and 7, and then dividing dividing by the total number of values in the data set, right? So basically what it means is take all your numbers, add them together, okay? Take all your numbers, add them together. So this is what I teach my kid when you're doing adding and subtracting. What are your common numbers? 5 and 5, 6 and 4. I'll try to write that a little better, guys. 6 and 4, 7 and 3. These all equal to 10. Okay, guys? This is how you do mental math in your head. Okay, these all add up to 10. Okay? 5 and 5, 6 and 4, 7 and 3, 8 and 2, 9 and 1. So, to do the quick math in your head, 7 and 3, 10. 6 and 4, 10. 10 plus 10, 20. That's how you do it. Okay? So the formula basically for the mean is the sum of the terms. You can call these all terms. So the sum, basically adding them all together, divided by the number of terms. How many terms do we have? We have 1, 2, 3, 4. Okay, we have 4 terms. Right? You can see that. There's 4 of them. Trying to get used to now, not to overcomplicate it, but it's obvious. We have 4. 1, 2, 3, 4. So you take your final answer and you go 4 into 20. Now we could turn that into a fraction, I guess, right? 20 divided by 4. And then we could do the same thing, the reducing. I'm doing all this without a calculator, guys. Again, we're working with small numbers, right? Times table in your head, you should know that what times 4 gives us 20. Well, that's 4 times 5, right? So our common number is 4, right? So I'm just going to try to squeeze it in here. We got 4 times 5 all over 4. What times 4 gives us 4? Well, that's 1, right? So these cancel. Our final answer is 5. Okay, I do apologize that it's kind of looks a little messy. Again, I know I should just erase all this, but you get the idea, right? I don't like that when I do that, so I'm gonna undo. If I clean up a lot of this, it would be easier. I should have kind of went like this. 5 and 5. I don't have any room there for it. 5 and 5. 6 and 4. 7 and 3. If you remember these numbers, they belong together. They all equal to 10. 8 and 2. 9 and 1. That's all you really need to remember. And then you could just group numbers in your head. Boom, boom. Quick math in your head. Okay? That was the idea, to show you that. Okay? Mental math here. That's what we're doing, guys. Okay? Using our noggin instead of a calculator. I kind of joke a little bit. You know, if I could teach my cat how to use a calculator, my cat could give me the right answer too. Okay, Jamie is twice. Let's see how we're doing on the time here. Not too bad. Okay, hold up, guys. I'm clicking the wrong things here. Okay, so that's how you calculate the mean. Okay, so Jamie is twice as old as Dan. Okay, so we're gonna try to figure out an age. Jamie is twice as old as Dan. So I'm gonna create a formula called 2D. Okay, 2 times Dan equals Jamie. All right. Dan is 3 times as old as Kim. Okay, man, this is gonna be a little tricky. All right. Well, we could kind of work this backwards somehow. Dan is okay. So Dan is 3 times. We're gonna have to think a little bit here, right? Dan is 3 times Kim's age. Okay, and Kim equals 4. Okay, so I could go, this is going to equal to D, and this is going to equal to J, and obviously 4 is going to equal to K. Okay, kind of creating our own variables. So really all I need to do is just kind of substitute this into there. That'll give us D, and then substitute D into there to get Jamie's age. So to show the work, we're just using variables to figure it out, guys. Okay, so Kim is 4. How old is Jamie? It asks. So obviously we're gonna have to figure out Dan's age before we can figure out Jamie's age, right? So here we go. So Dan, just go like this. D trying to write this. I'm trying to be fast, but also trying to want to write it nicely too. 3 times K, which equals 3 times 4. Therefore, D is equal to 12. Okay? So that is Dan. Okay, that's Dan. So to figure out Jamie's age, we know that Jamie is twice as much as Dan. So J equals 2D, which equals 2 times D, which is right here, 12. J is equal to 24. Basically, we just double this and double that. 2 times 2 is 4. 2 times 1 is 2. So our answer is 24. That easy, guys. You can create your own variables, guys. That's why variables are invented. So you can do that. So that's the correct answer, 24. All right. Okay. You worked 7 hours each day of the week except Sunday. Okay, so we know, we got to think about this, right? So we know that there's 7 days in a week, right? This is common sense stuff per week. Okay, so it's saying that we worked 7 hours each day of the week except Sunday. So basically we could go 7 minus 1, right? Because we're taking off Sunday, so we're left with 6 days. So they're working 6 days a week, and they're working 7 hours each of those days. Okay, how many hours did you work in the week? Okay, this is just for 1 week, right? So we figured it out. Okay, we figured it out. They're only working 6 days a week. They get 1 day off, which is Sunday. Perfect. Every single one of those days, they're working 7 hours. So all we have to do is just basically take however many days and multiply it by how many hours. Okay, so 6 times 7. Again, if you have your times table memorized, 6 times 7 is 42. Whoops. I really don't like when I do that. I don't know how to get rid of that. It's weird. I don't edit in PDFs, so anyway, so there we go, 42. So, they're not giving us an hourly, so but basically 42 hours for that week. And I could write for that week. I mean, every week could be different, or maybe they're consistent. If we go for the whole month, it would be this times 4, right? Okay, 42 is the answer. Pretty simple math. Again, we're just kind of doing easy mental math stuff, guys. That's all it is. Okay, a normal work week is 40 hours. Okay, so that's 1 week, right? I could write it all out. We're doing a new problem. Okay, a normal work week is 40 hours. Okay, all right. Okay, that's true. That's usually common. All right, if you work 52 hours, how many hours of overtime did you work? This is simple math. I mean, maybe you're new to working a new job or whatever. This is fine. You probably don't know you don't understand or know how to do any of this stuff, so let's just figure it out. Okay, a normal work week is 40 hours, so that's regular. That's what would be called regular hours. Okay? So, but you worked 52 hours because you want to make the money. You want to make the money. Okay? Bling bling. Okay? We all have to make money. Okay? Guys, somehow. Alright? So, 52 hours is what you worked for that week. How many hours of overtime did you work? Well, it's simple math, right? So you know 40 is regular. Anything over 40 is called overtime. So we have to do a little subtracting. 2 is larger than 0, so we don't have to borrow. So we can bring down the 2. 5 take away 4 because 5 is greater than 4. 5 take away 4 is 1. We don't have to borrow. Borrowing happens when the top number is lower than the bottom number. Okay? For example, if this was 0 and this was 8. I gotta erase everything. I'm gonna bring it all back. Okay? For example, if this was 0 and this was an 8, that's what I'm talking about. We would have to borrow because 8 is... This number here has to be lower or less than the number above it. Okay? So borrowing basically means I have to borrow from the 5, which gives me 4. That makes this a 10. We're left with 2. Simple math. Okay? Alright, so our answer is 12. And we're not given an hourly. It just depends, right? Usually it's 1.5 times your regular rate. Okay? So basically it would be, it worked out to be 12. It would be 12 times 1.5 times whatever you make per hour. Let's say you make, I don't know, $18 an hour. Okay? And then you would have the 40 regular on top of it, which would be times 18. Okay? Which would equal a value. So, I don't mean to confuse everything here. 12 times 1.5 times your regular. This is your regular rate. 40 times your regular hours. You have overtime hours, right? 40 plus 12, these are your hours. And then you total that. So 40 times 1.5 times 18. I'll just do it quickly. 12 times 1.5 times 18, which would equal 324. That's the overtime money. And then the regular. 40 times 18 is your regular, which is 720. These you would add together. Just did it quickly on the calculator. 144. Okay. And then of course, good old taxes get taken off of that too. So that's that. Okay. Last question here, and then there's actually probably 1 or 2 more videos of this. I want to try to get this finished up, guys. Okay, how many more hours must you add to 5.5 1/4? 5.25 is 5 1/4. How many more hours must you add to 5.25 hours to have a total of 8 hours? Well, we're at a point where we're subtracting decimals. So what plus 5.25 equals 8 essentially is the question. So now working with decimals, guys, okay, there's only some basic rules of math that you have to remember. When you're adding and subtracting decimals, you have to line up the decimal. Okay? But when you're multiplying, you don't. Let's say we're multiplying it by, I don't know, 2.5. Actually, that's a terrible example. Let's go 41.2. I'm still technically lining up to decimals. How do I do that? With multiplying, you don't really have to. Let's say, yeah, here's an example. Let's say it's just by 8, right? Here's the decimal there, right? You don't need to line up the decimals, but with adding and subtracting, you do. Okay, that's kind of my main point, all right? So this is kind of where we're going to be borrowing, so we have to subtract. Okay, 0 is smaller than 5, so we have to borrow. I think the easiest, smartest way to do this, how do we do this? I could go like this. I want to borrow from from the 80, so I'm going to get 79. I'm going to put a 1 there. I borrowed 1 from 80, which gives me 79, which makes this a 10. Essentially, I have a 10 right there. 10 take away 5 is 5. Now we have 9. 9 is greater than 2. That's what we want. So we could actually straight subtract. What plus 2 gives us 9? Well, that's 7, right? Decimal is there. Just bring the decimal down. Subtract here. 7 take away 5 is 2. And there it is. That is subtracting decimals 101. We're kind of doing a lot of different stuff, guys, and it doesn't hurt to reflect and kind of just go over this stuff again. Maybe it's been a number of years since you kind of went over this. It doesn't hurt to refresh your memory, you know. Again, you can see my little trick here, right, guys? When I borrowed from the whole thing here. I borrowed from the 80. Instead of trying to do it twice, because you can't really borrow from a 0, right? Makes sense? So if we do the math, if we do the addition, if I actually now, to check my answer, I could actually add 2.75 just to check my answer. Like, you know it's right, but you can check your answer, right? So again, it's addition. You can line up the decimals. They are in line here. I know they're a little off kiltered, but that's fine. 5 plus 5 is 10. Carry the 1. 7. This is 2 plus 1 is 3. 7 and 3, right? 5 and 5. 6 and 4. 7 and 3. 8 and 2. And 9 and 1. Whoops. 9 and 1. Right? Again, these are your magic numbers right there. I always call them the magic numbers, but I call everything the magic numbers, apparently. They all equal to 10, right? We know this. So 7 and 3 is 10. Carry the 1. 5, 6, 7, 8. And bring down the decimal. Boop. Big yays. Okay, I'm going to end it at that, guys and gals. Stay tuned. I'm going to, as a matter of fact, let's quickly leave you with one problem to work out. And then stay tuned. Come join the next video, and I'll work out the problem for you. All right, so this is for you. Give it a shot. Try it out. Okay, so there are 6 candies in a box. 60, sorry, my bad. Okay, each box. So we have a box of candies. There's 60 in them. Okay, 60 candies per box. Okay, if you eat one candy each day, so I don't know how many kids can only eat one candy a day, but okay. Brush your teeth, kids. That's what I recommend. Okay. I'm just saying that because I wasn't perfect myself when I was younger, and I'm just trying to instill for you guys. Yeah, it's important. Brush your teeth, guys and gals. Um, here's the thing. It builds having nice teeth. Builds confidence. Well, it doesn't really build it, but you lose confidence if you don't. If they aren't. You understand? I hope so. Brush your teeth. Let's go. Okay, it's important. Especially before bed. That's the time that you want to do it. The most important. Mornings is kind of just to get rid of the morning breath. Nighttime is when the things happen while you're sleeping, you know? Anyways. All right. Okay, so 60 candies in a box. If you eat one candy each day, how many candies are there in the box after 8 full weeks? Wow. So, how many are left? So, how many? I'm going to try to write this out. How many left? How many left in the box? Okay, this is a box of 60. After 8 full weeks. It says full weeks. 8 full weeks. Okay, so hint is to figure out how many days. Okay, that's my hint. And you're only eating one per day. One per day. Okay. All right, I'm going to leave it at that. And we'll see you guys in the next video. Appreciate you watching. You're awesome. Awesome. Turn it up. Johnny here, Whiskey Tango Sharp. Coding and everything going on over here. Here to support you, parents, students, in mathematics. Some of you may, have some difficulties. Stay tuned, follow along, guys. I'm going to do a lot of different random mathematics stuff. Eventually, we're going to be kind of getting into standard grade 9, 10, 11 mathematics program here. All right, appreciate having you. Don't forget to hit the like, subscribe. I'm not going to pressure you guys and gals, but the support of the channel, definitely appreciate it. That is it. Much love, take care, and we'll see you in the next video. Take care for now, guys. Peace.